By the end of 2026, 40% of enterprise applications won't just answer your questions.
Right.
They will independently log into your CRM, negotiate a vendor contract, and execute a fully customized marketing campaign while you're asleep.
It's honestly wild to think about.
It really is. That's a forecast from Gartner, and it means we're no longer talking about AI as this simple tool where you type a prompt and get a summary back. We're looking at artificial intelligence executing entire complex business goals completely on its own. Here's where it gets really interesting, though.
Yeah, the shift from a tool to an autonomous workforce, I mean, that is the defining technical hurdle of this decade.
Absolutely.
And for you listening today, whether you're, a European CTO mapping out your next quarter, or a developer building these systems, or even just a business leader trying to figure out where your budget is actually going, this changes the entire math of your operation.
Because right now, a lot of organizations are still treating AI like a very expensive, incredibly fast calculator.
Yeah. Exactly. But the paradigm has completely moved. The capabilities separating the companies actually seeing real ROI from the ones who are just, burning compute credits is what we call multi-agent orchestration.
Multi-agent orchestration. I mean, it sounds like managing a digital symphony or something.
It kind of is, yeah.
But from the AetherLink research we're diving into today, it's actually about survival. So our mission for this deep dive is to unpack how deploying these multi-agent systems delivers measurable ROI, how they completely bypass traditional integration costs,
and this is the crazy part.
Yeah, how this architecture turns strict European privacy compliance into a competitive moat rather than a bottleneck.
Right, which is huge for our European listeners. Aferlink, being a Dutch AI consulting firm, really highlights this.
Totally. But before we get into the massive cost savings, we really need to understand the mechanics here. How does AI actually make this leap from a simple chatbot to a functional workforce?
Well, it requires a fundamental change in the architecture. I mean, traditional generative AI is a single-loop process.
Right. You ask a question, it predicts the next words and stops.
Exactly. It's a one-to-one transaction. A multi-agent system, however, is persistent. It's goal-oriented. So instead of relying on one massive generalized brain to do everything, you deploy this choreographed network of highly specialized AI agents.
Okay, but to prevent that network from just collapsing into a chaotic loop of errors, the system relies on 4 distinct architectural layers.
Maybe it does, yes.
Before we list out those layers, let's ground this for a second. What does it actually mean for a system to be self-correcting without human intervention?
That's the key question.
Because, I mean, if a traditional LLM hallucinates, I just roll my eyes and type a new prompt.
Yeah.
But if these agents are running autonomously, passing data between each other in the background, couldn't one hallucinated number just cascade and ruin the whole project?
Oh, that is the exact nightmare scenario.
Right.
And it's exactly why the architecture has to be segmented. So the foundation is the agent layer. These are your specialized workers. One agent might only be trained to write SQL queries to pull data, while another is, only trained to evaluate the tone of an email.
So they don't overlap at all.
No, they stay in their lanes. Yeah. Above them sits the orchestration layer. Think of this as the manager.
Okay.
It doesn't do the actual work. It just dictates how the agents communicate, the order of their operations, and most importantly, it handles conflict resolution when an agent fails.
So the orchestrator is the thing that catches the hallucination before it propagates.
Correct. But to do that, the orchestrator needs ground truth, which brings us to the third layer, the knowledge layer. This is where we see mechanisms like retrieval augmented generation, or RAG, paired with vector databases. This feeds specific factual enterprise data to the agents so they aren't just relying on their pre-trained internet knowledge.
Right. Let's pause on vector databases for a second, because that term gets thrown around a lot in boardrooms right now.
Oh, constantly.
If I'm understanding the AetherLink notes correctly, a traditional database is like a rigid filing cabinet, right? You search for a keyword, you get that specific folder.
Yep.
But a vector database maps concepts spatially. It converts your company's data into numbers, or vectors, so the AI can understand the contextual relationship between ideas, not just exact word matches.
That is a really highly accurate way to visualize it. I mean, if an agent asks the vector database for, say, customer churn risks, it doesn't just look for the word churn.
It looks for the meaning.
Exactly. It pulls context about declining login frequencies, missed payments, negative support tickets, feeding all of that to the agent.
Wow.
And finally, wrapping around all of this is the governance layer. This is the hard-coded infrastructure enforcing compliance checks, audit trails, and deterministic guardrails.
Okay, so if we look at this like a corporate marketing department,
Yeah.
you would never ask your brilliant graphic designer to also run the company payroll.
No, that would be a catastrophe.
Right. So in this architecture, specialized agents handle specialized tasks under the watchful eye of the orchestrator.
Precisely.
But wait, I assume there's a massive latency cost to this?
Yeah.
If the orchestrator has to constantly evaluate which agent to use and constantly verify their work against a vector database, doesn't that just slow the whole process down to a crawl?
Well, it introduces complexity, certainly, which is why the topology of that orchestration layer is so critical. The orchestrator actually has to decide between sequential and parallel execution.
Okay, what's the difference in practice?
So parallel execution is launching multiple agents simultaneously to handle independent tasks. It's incredibly fast, but it dramatically increases the risk of those cascading errors you mentioned earlier if the agents produce conflicting data.
Okay, so if parallel is faster but way riskier, I assume these companies are building some kind of hybrid, like letting the AI run wild on data gathering in parallel, but putting a hard sequential stop before it touches the budget or, sends an external email.
You've hit on the exact industry standard there. They use sequential execution for high-stakes actions.
Makes sense.
In a sequential flow, Agent A must completely finish its work, and the orchestrator must verify it against the governance layer before Agent B is even allowed to wake up.
Oh, wow. So it's a hard stop.
Exactly. It acts as a physical gate.
Yeah.
The process simply cannot move forward until that gate is cleared. You get the speed of parallel processing for the heavy lifting and the clear causality of sequential processing for the critical decisions.
You put the guardrails where the cliffs are.
I like that, yeah.
It makes sense mechanically. But taking a step back, running multiple high-powered AI models simultaneously, constantly pinging vector databases, token costs add up quickly.
Oh, they absolutely do.
I mean, that sounds like a CFO's worst nightmare.
It is, and without a strict framework, the compute costs will outpace the business value. AetherLink actually refers to this as the cost optimization imperative. Because if a developer defaults to using a massive bleeding-edge reasoning model, like the heaviest versions of GPT-4 or Claude, for every single microtask in the pipeline, the budget exposure is catastrophic.
So how do they solve that?
The breakthrough here is a strategy called cost routing.
Cost routing.
Yeah. The orchestrator dynamically evaluates every incoming task based on 3 metrics: required accuracy, acceptable latency, and token cost.
Okay, so it's basically the realization that you pay for the exact level of capability required.
Exactly.
It's like hiring a highly paid, brilliant senior executive to draft a complex corporate strategy. You need a massive reasoning engine for that.
Yes, you do.
But you absolutely do not pay that senior executive's hourly rate to copy and paste that strategy into a PowerPoint deck.
Yeah.
You delegate the data entry to an intern.
That captures the economics perfectly. You route the complex, multi-step planning tasks to the massive, expensive models. But for the execution, say, formatting a JSON file or generating the actual text of an outreach email, the orchestrator routes that to a much smaller, highly fine-tuned, and significantly cheaper open-source model.
That's brilliant.
And by optimizing agent selection dynamically like this, enterprise organizations are seeing a 73% reduction in per-task execution costs.
73%.
While maintaining the exact same quality of output.
A 73% reduction completely changes the math on whether an AI initiative gets funded or killed in committee.
It really does.
But the token cost is only half the battle, right?
Right.
If I'm a CTO listening to this, I'm thinking about integration.
Right, the plumbing.
Yeah, plugging a dozen different AI agents into a legacy tech stack, writing custom API connectors for the CRM, the billing software, the HR platform. I mean, that is where enterprise software budgets traditionally go to die.
And historically, you'd be right. Developers were spending months writing bespoke, brittle API plumbing for every single tool. But the landscape is shifting rapidly due to the adoption of standardized interfaces.
You're talking about the Model Context Protocol, right? MCP.
Exactly, MCP.
The source notes described MCP as a universal translator for AI, but what does that actually look like under the hood? Like, how does it bypass custom APIs?
Well, think of MCP like the invention of the standardized shipping container.
Okay.
Before shipping containers, loading a cargo ship meant packing 1,000 differently shaped boxes, barrels, and crates. It took weeks, and every ship needed a custom loading plan.
Right, a logistical nightmare.
Exactly. MCP is the shipping container of the AI world. It standardizes how external tools and databases package their data for an AI to consume.
So they all speak the same language.
Yes. The CRM system doesn't need to know what kind of agent is asking for the data, and the agent doesn't need to understand the underlying architecture of the CRM. They both just speak MCP.
So the developer just plugs the agent into the MCP server, and it instantly has read and write access to any connected tool.
Yes, exactly. And the financial impact of that standardization is just profound.
I can imagine.
Forrester's 2026 benchmark data indicates that multi-agent systems utilizing MCP standards reduce integration overhead by 67%.
Wow.
For an enterprise managing dozens of specialized agents, that translates directly to $2 to $4 million in annual development cost saving.
That's massive.
Furthermore, it completely eliminates vendor lock-in.
Oh, right, because you aren't tied to one ecosystem.
Exactly. A company can use one vendor's specialized compliance agent, a different startup's market analysis agent, and an open source reporting agent, and they all communicate seamlessly under one orchestrator.
Which brings us to the massive, highly regulated elephant in the room for our European listeners.
The EU AI Act.
Yes. If you are building this architecture in the EU, you are dealing with the EU AI Act. And we know that European enterprise adoption of AI agents is lagging behind North America by about 6 to 9 months right now because of these strict certification and compliance requirements.
Sure.
Usually the narrative is that this kind of regulation is a speed bump that kills innovation. But the AetherLink research argues that this architectural model actually turns the EU AI Act into a competitive advantage.
It does?
So how does adding more red tape actually help a business?
Well, it comes down to understanding why the regulators are terrified of older AI models and why multi-agent systems solve that fear mechanically.
Okay, explain that.
Previous generations of large language models were monolithic. They were giant, impenetrable black boxes. If a monolithic AI evaluates a customer profile and denies them a loan, and a European regulator asks the bank, why did the model make that decision?
The bank literally can't tell them.
Exactly. The bank often cannot provide a mathematically clear answer. The reasoning is smeared across billions of hidden parameters. And under the transparency demands of the EU AI Act, deploying a black box for a high-risk decision is a massive legal liability.
But because multi-agent systems are modular, and because they use that governance layer we talked about, you can actually trace the exact steps.
Yes.
What does that audit trail look like in practice, though?
The governance layer enforces 4 hard-coded controls. The first is action logging. Every single time an agent touches data, the system logs a timestamp, the exact vector data it retrieved, the prompt it was given, its reasoning trace, and a mathematical confidence score.
Wait, let's drill into that for a second. How does an AI calculate its own confidence score? That sounds a bit subjective.
It's purely statistical, actually. When a model generates a response, it's calculating the probability distribution of the next correct token. If the probability spread is highly concentrated, the model is mathematically confident in its answer. If the probability is flattened across many possible answers, the confidence score drops.
Ah, I see.
And that ties directly into the second governance control: escalation triggers.
How so?
If an agent's confidence score drops below a preset threshold, say 85% on a high-risk task like a financial transfer, the system automatically halts and routes the package to a human manager.
So it literally raises its hand and says, the math indicates, I might be guessing here, I need human oversight.
Exactly. It refuses to guess. The third control is model transparency, meaning the known limitations of every fine-tuned model are documented in the orchestrator.
Yeah.
And the fourth is user rights support. Because the system's reasoning is logged step by step, the orchestrator can instantly translate that log into plain language to satisfy the GDPR right to explanation.
That's amazing.
You can audit, isolate, and test every single agent without tearing down the whole system.
There's also a fascinating mechanical advantage here regarding privacy by design.
Oh, absolutely.
Because the agents are modular, you aren't forced to send all your proprietary data to a massive cloud provider. The source details how modern orchestration allows for localized execution.
Right.
So if an agent needs to process highly sensitive customer PII, like a scanned passport or a medical history, the orchestrator can route that specific task to a smaller model running locally on the company's own bare metal servers. The sensitive data physically never leaves the building,
while simultaneously routing the non-sensitive, compute-heavy tasks like, say, summarizing a public industry report out to the cheaper cloud APIs.
Right.
It's the ultimate balance of privacy and cost efficiency. This is exactly why building deterministic guardrails creates a defensible moat for European companies.
Because the competitors can't do it.
Right. If you master this compliant, localized orchestration, you can deploy AI into finance, healthcare, and insurance markets, where your North American competitors who are still relying on non-auditable, cloud-based black boxes simply cannot legally operate.
Wow. It's easy to talk about these guardrails and cost routing in theory. But when an enterprise is processing tens of thousands of live customer interactions a month, those sequential gates sound like a massive bottleneck.
They can be if designed poorly.
Let's look at the AetherLink case study of the mid-market SaaS company to see how this actually functions under pressure.
Yeah, the operational friction in this case study is incredibly common. This SaaS company was generating 50,000 marketing leads a month.
50,000.
Yeah. But their human team was spending over 200 hours a week manually reviewing these leads, trying to prioritize them, and drafting personalized outreach.
That's a massive resource drain.
And even burning all those hours, they only had the bandwidth to reach 15% of their leads with personalized content.
Which means 85% of their expensive marketing funnel was just receiving generic spam or falling through the cracks entirely.
Exactly. So they deployed a 4-agent hybrid sequence. First, a lead segmentation agent independently queried their CRM, analyzing behavioral data to classify leads into 8 distinct buyer personas.
Okay, and once the segmentation agent logged a high confidence score, the orchestrator triggered the second phase in parallel, right?
Correct. The content generation agent consumed that persona data and drafted highly specific email copy tailored to the lead's industry pain points.
And then the sequential orchestration kicked back in.
Yes. The timing optimization agent analyzed the recipient's geographic time zone and historical open rates to calculate the mathematically optimal minute to send the email.
And before anything actually hit the outbound server, it went through the quality gate agent.
Yes, my favorite part.
Right. This final agent acted as the compliance officer, reviewing the generated text against brand guidelines and GDPR consent flags. If a message was borderline, it escalated to a human. But if you're a developer listening to this, you're probably thinking, sure, that sounds amazing, but what was the upfront cloud compute cost to train and build a specialized 4-agent hybrid? You don't just flip a switch and get that level of reliability.
You really don't. And the upfront investment in architectural design and rigorous evaluation testing is substantial. But it is non-negotiable.
Yeah, they didn't just let it loose on day one.
No, the case study highlights that for the first 500 leads, the orchestrator was hard-coded to require manual human approval for every single AI-generated message.
Wow, every single one.
Every single one. It was a strict pilot phase. They measured accuracy, latency, and cost efficiency in real-world conditions. They only dropped human oversight to a 10% random sampling rate after the agents consistently hit their accuracy benchmark.
That's the evaluation phase you were talking about.
Right. And organizations that skip that formal evaluation phase suffer failure rates 3 to 4 times higher than the industry average.
But once that evaluation phase cleared, the operational metrics were just staggering. Their personalized outreach coverage went from 15% to 89%.
Incredible.
The manual human review time plummeted by 86%, dropping to just 28 hours a week. And because the messaging was actually contextual, reply rates jumped 34%.
And the runtime cost is what really proves the cost routing theory we discussed earlier.
Right, the token costs.
The cost to generate a personalized message dropped from €2.40 down to 12 cents.
12 cents. That's insane.
That 12-cent metric is the tipping point for enterprise adoption. By relying on smaller, cost-routed models instead of monolithic APIs, they netted over €180,000 in annual savings. They achieved full ROI on their initial development costs in just 4 months.
4 months. But the roadmap to get there requires discipline. You don't try to automate your entire enterprise at once. You start with 3 to 5 agents focused on one highly specific, measurable business process.
Exactly. The sources outline a very strict pilot to production timeline. You run the pilot on 100 live transactions. You evaluate the vector retrieval accuracy. You tweak the orchestrator's latency. Then you expand to 1,000 transactions.
Scaling up slowly.
Yes. Only when the confidence scores are stable do you open it to full production traffic. That entire life cycle should take 60 to 90 days.
And importantly, the work doesn't stop at day 90. Enterprise data is not static, right? Customer behaviors change, new products are launched, macroeconomic conditions shift.
Yes, this causes what we call data drift.
Data drift.
Meaning the underlying context your agents are relying on degrades over time. You have to implement quarterly reevaluations against your baseline benchmarks to recalibrate the agents before that drift impacts your bottom line.
Wow. We have covered a massive amount of technical and strategic ground today, from vector databases and MCP to the mechanics of the EU AI Act.
We really have.
As we distill all these AetherLink insights down, what's your number one takeaway for the listener?
For me, it has to be the sheer economics of cost writing.
It's a game changer.
It really is. The realization that you don't need to rent a supercomputer to do the job of an intern. By dynamically evaluating tasks and routing them to the appropriate model size, you cut execution costs by over 70% while actually improving speed. It fundamentally changes the viability of AI in the enterprise.
That dynamic routing is certainly the financial engine of this shift.
Yeah.
But for my primary takeaway, I look at the structural advantage it creates.
Okay, the compliance side.
Yes. The realization that modular multi-agent architectures flip strict regulation from a liability into an asset is profound. By moving away from monolithic black boxes and utilizing a governance layer with hard sequential gates, action logging, and confidence scores, European companies are building deeply trustworthy, auditable systems.
Right.
It forces a level of architectural rigor that ultimately creates a massive competitive moat.
Regulation as the blueprint for a stronger fortress. It's a great perspective. But it also leads to a fascinating technical horizon, and this is what I want to leave the listener to mull over. Everything we've analyzed today focuses on an enterprise's AI agents working together internally, safely behind a corporate firewall.
Sure.
But as standardized protocols like MCP and new agent-to-agent standards become universally adopted, we are going to see a fundamental shift in external B2B operations.
Oh, wow.
What happens when your fully autonomous, perfectly orchestrated multi-agent system has to independently negotiate a fluctuating supply chain contract or resolve a complex billing dispute with the vendor's autonomous multi-agent system?
That's a wild scenario.
How do two completely distinct AI workforces securely establish cryptographic trust, argue legal terms, and execute a binding agreement without a human ever picking up the phone?
That is an incredible thought to end on. Two autonomous workforces shaking hands in the digital space, negotiating at the speed of compute. The multi-agent architecture we unpacked today is really just the foundational layer for that reality. Thank you so much for joining us for this deep dive into the mechanics of the autonomous enterprise. For more AI insights, visit AetherLink.ai.